Hello guys, welcome back to my channel Memo African Motives, still working on engineering science and 3. So in this platform we shall actually focus on the question paper which was written in March 2016, which is on moments. We want to see how they asked these questions on these late questions that we had before, so that we can at least understand that there is no difference from these typical question papers like this and the recent question papers. Actually, what is happening is that most of the recent question papers that we are having now, the information is just taken from these past papers, because most of us, we don't work on them, and that is where these questions are being taken and so forth. So you shall quickly see this, and you understand, and you'll bear with me that there is just a repetition that you're talking about in this case. Okay, so as you can see, the question 2 there on moments is actually 13 marks for that. So that is what we have. So if you are new guys to this channel, you can consider subscribing so that you become part of the family Memo African Motives, working on question papers and revisions for engineering science and 3. So in this case, you are given to state the definition of a force. So as usual, I always have definitions that are according to the syllabus, so that we do not divert from what the syllabus needs us to answer these questions. So a force is something that we can define. A force is that influence which changes or tends to change the state of rest of a body. If a body is already moving, then a force is that influence which brings the body to rest or changes the direction of the body. So when it is already moving, but any influence that is that changes or tends to change the movement of a certain object is actually a force that you're having there. All right, then this is the part that we just want to quickly rush through and see what we are given there. All right, on this question we are given that a uniform beam is 18 meters long and rests horizontally on 2 supports. The one support is on the left side and the other support is 4 meters from the right side. Okay, so this one is on the left side and this one is 4 meters from the right side. All right. The beam carries concentrated loads of 200 and 100 Newton, 5 meter and 10 meter from the left end respectively. So which means we've got this one, which is 5 meter, which is 200 from the left end respectively. So this one is going to be 200. Let me just use this one so that maybe it gives us something better there. So you've got 200 there, Newton. All right, then this one is 100. As you can see, 5 plus 5, that's 10. So this is where you're going to have our 100 Newton this side. So these are the concentrated load that we are given. All right, respective, which means following each other. The beam carries a uniformly distributed load. This is what is important here, of 50 Newton per meter over the first 6 meters from the right end, which is this first 6 meters from the right end. All right, so you know that whenever you're given a distributed load like this, we're supposed to have it as a concentrated, which means you're going to multiply 15 by 6. So if you multiply 15 by 6, guys, that is going to give us a 90 there, which is in newtons. All right, and you're going to divide the distance because we've got 6 meters here, so which means we're going to have 3 meters. But take note, here we've got 4 meters, so which means 3 meters is actually in between here, because this one is 4 meters. So take note, I'm just going to use this diagram today, guys, so that we just see this. I'm just going to draw something like this. All right, so which means 3 meters is somewhere in between here. So remember, if we multiply 15 and 6, we obtained 90 Newton, like that. All right, and also we say the distance is going to be divided into 2, so which means from this point here, okay, let me just have it a continuation like this. All right, from this point to this point like this, we have got 3 meters here. All right, and also from this point to this point like this, we have got 3 meters there. All right, but I want you to take note, because before we had 4 meters, from R to the right end here is 4 meters, so which means in between here we have got 1 meter in between here. There is 1 meter in between here. Take note, this is 1 meter in between, because it's supposed to be 4. This 3 from this point to this point is 3. So 3 plus 1 should give us this total of 4. All right, which means if this is 1, which means from this point to this point, you're going to be left with 2 meters from this point to this point. Okay, I shall talk about it later on, but as you can see, that is what we are having here. We're going to be left with 1 meter in between these two here. All right, so the question is, calculate the reactions at the supports and test your answers. Okay, so definitely reactions, guys. Okay, we need taking moments. You're going to start with moments about L. Taking moments. All right, about L. Is it? Let's just start with L. Okay, so taking moments about L. Let's see about L. If you are to cross check, R is the one that is going to start. We are going to start with R. As you can see, R is going to move this direction, which is this direction. That is anti-clockwise, guys. From this point, it's anti-clockwise there. All right, so which means we are going to work with anti-clockwise moments equal to the sum of what? Clockwise moments. So let's just quickly have this sum of anti-clockwise moments equal to the sum of the clockwise moments, like that. Okay, so like we said, this is from R to L is going to be anti-clockwise. I think now we are used, guys, to this movement. This one, this direction, it's anti, so it's R times 14, or 14 times R. So 14 times R, like this. Do we have anything that is still going in the anti-clockwise? All right, let's just put our support here like this. All right, so as you can see, it's only R that is going this direction. All these forces, they're going to come this way. This one is going to come this way. This one is going to be taken this way, which is clockwise. As you can see, this is the way the clock moves. This is clockwise. So all these forces are on the clockwise side. Okay, so there's nothing on the anti-clockwise except of this one. So all these are on the clockwise. So it's 200 times 5. The difference here between 200 and 5, so it's 200 times 5. All right, that's 200 by 5, plus we move on to this one. It's actually 100 back to L. This is your L, so it's 100 back to L. So as you can see, it's 5 plus 5, which is 10. So it's 100 by 10. All right, that's gonna be 100 by 10 plus. All right, we move on to this one here, 90. So this is important, guys. Let's add properly here from 90. This is 5 plus 5, which is 10. 10 plus 2, which is 12. And 12 plus 3, we are adding this whole 3, which is 15. So we are going to have 15 there. So it's 90 times 15. You add the distance properly there. All right. So that's going to give us 14R in this case, which is equal. So you can combine this at once, or you can choose to do it separately. That's 1000 plus 100 times 10, which is 1000, plus 90 by 15, which is 1350. So you can choose to do this, or you can just add them direct, which is 3350 there. So to find R, definitely have to divide by 14. By 14, there's no way. So our R is going to be this decimal, guys, 239,285714, something like that. Okay, so you can just round this to 3 decimal places, which is going to give us, what are we going to have? So going to be 239, that's 123. Yeah, that's what I did here. So it's 286. That's your R here, and these are newtons, guys. Everything is in newtons, so there's no way your R also is going to be just newtons like that, not kilo, because others are in newtons. So you're just going to leave it in newton like that. All right, so here we're taking moments about L. So an opposite, now we are going to take moments about R now and see what you're going to have. So let us just quickly do this, guys. That's taking moments like this about R. All right, yeah, it's about R this time, not L, because L we are done with you. So now let's take moments about R, guys. So as you can see, L is going to move this way. This is the direction of L, is going to do this direction. So as you can see, this direction to R is in the clockwise. Remember we talked about this direction, guys, it's clockwise. So this time I'm going to start with clockwise because L is moving in a clockwise. So clockwise, sum of clockwise moments is equal to sum of anti-clockwise moments. So it depends, guys, with your formula. If you start with this, therefore you're going to start with anti-clockwise. If you start with clockwise, as for me, I want to start with clockwise. That's why I use this one. So L back to R here, there's a distance of 14. So it's 14 times L. So we are going to have 14 times L like this. Do we have anything that is moving in a clockwise? Okay. This is our R here, guys. Remember what we said. This is our R here. Okay. Clockwise is this direction. This is clockwise. All right. Because this is pointing upwards, that is why it's going to move this way in a clockwise. Let's cross-check these ones which are pointing downwards. This one is going to move this direction, which is this direction, anti-clockwise. As you can see, anti-clockwise. Also, this 100 is going to move this direction, which is anti-clockwise again. But I want you to cross-check because, guys, this is your R here. And we say there's a distance of 1 meter between this 90 and R. So which means this is on the other side of R. So take note about this one. Let's take how this force is going to move. This is going to move this direction from 90 back to R is going to move this way, which is, are you seeing that we are maintaining the clockwise? So this 90 is going to be in the clockwise. All right, so it's going to be part of this because it's on the clockwise. So it's going to be part of this one. So it's going to be 90 times the distance between, and we say there's a distance of what? Of 1 meter. You see this issue of writing it down. So it's 90 times 1. There's a distance of 1 meter there. So it's plus 90 times 1 like this. All right. So what are we going to have now? Because this is what we just have on the clockwise. On the clockwise, and these ones we say they're anti-clockwise. These ones, as you can see, 200 and 100, they're in the anti-clockwise. So we're going to combine them together. So 200 is going to be, let's see the difference here. So it's going to be 200 times, what is the distance? The distance here, we are going to have 5 plus 2, which is 7. But take note, guys, we are supposed to take it to point R here. This is like this, guys, to point R like this. So this is not 3 because there's a difference of 1 meter here, and we say this is 2, so it's going to be plus 2. So it's 5 plus 2 plus 2, which is 9. So 5 plus 2, that's 7. 7 plus 2, which is 9. So it's going to be times 9. All right. Plus, also this one is on the anti-clockwise because it's going to move this way. It's anti-clockwise. So it's 100 times, let's see the distance between 100 and R here. So it's 2 and 2. So 2 plus 2, which is 4. So it's 100 times 4. All right. So we are going to have 14L plus 90, which is equal. So guys, you can combine just like what we did in the previous part. We add this. So you're going to obtain 2,200 in this case. This is what you're going to obtain. 2,200. Then you subtract this 90 because it's a plus. So you're going to subtract it. If you transpose this to the other side, which means you're going to subtract 90 there. So you're going to be left with 14L is equal to this one minus 90 is going to give you 2,110. So this is 2,110. Divide by 14 because you want to calculate L there. So therefore your L is going to be, just divide properly, you're going to obtain 150,71428, something like that. Yes, 7142 something, which is going to be 714. So it's newtons there. So that is the L that you're having. So as you can see, guys, after rounding off, we're going to obtain 150,714. So the question is not just to calculate the reaction, we are supposed to test the answers now. So how do you test? We know that the sum of the upward forces should be equal to the sum of downward forces. So let us just test. The sum of the upward forces should be equal to the sum of the downward forces. That's what we know. All right, so let's just put this L. We have the value of L, which is 150 comma this one. That's our L here, which is 150 comma 714, like this. Okay, this is our R here, which is 239. Yeah, this was 239 if I'm not mistaken. This was our R here, which was 239 comma 286. Okay, this was 286, guys, if you do remember. All right, these are in newtons, these are in newtons. All right, so we know that the upward forces, these are the reactions, which is L and R, these ones which are going up. So these are the upward forces that you're talking about. So you're going to add L plus what? L plus R, which is you're adding these two together. Okay, so it's 150 comma 714 plus 239 comma 286, like this. These are the ones which are going up, the supports, and all the point loads are the ones that are going down, which is 200, 100, and 90. So you've got 200 plus 100 plus 90, like this. Okay, so this is, remember, these forces are in newtons, so your answer is going to be also in newtons there. All right, so if you add properly, you are going to obtain 390. Is it 390 or 320? That's 390 newtons, which is also 390. These are newtons, not kilonewtons, but newtons. You are adding newtons, so your answer is going to be newtons. It can't be a miracle to change from newtons to kilonewtons just like that. All right, so that's what we had. Then on this question, which is calculate the turning moment about the fulcrum in fig 2 below. All right, we need to calculate the turning moment, which is this force here. That is the unknown force that is at the angle. That is the turning moment there. All right, still it's on the same thing like this, because we are talking about moments. We are still on the same thing like that, but this time, how are we going to apply our moments? Okay, since we want to calculate this unknown force here, let's just say this is the unknown force F in kilonewtons, like that. We know that, guys, this support, just like what we had, these supports here are the ones that we are going to use when you are referring to moments. So we need this support here. So let's just say this is our left and this is our right here. All right, so when you are talking to the support, you are talking about this distance here. This is the one that let's just refer to the distance like this part here. So how are we going to determine this distance? Because we are just this one we are given like this. Let me redraw so that you can understand what I'm saying. We are given something like this. There is an angle which is in between there of 30 degrees, like this, and we want to calculate this reaction. This is the reaction that we want to calculate. We say this is F kilonewton. We do not know this, so we must take this F to be written here, because this is the side that we need. So this F should be written here, just like what we have these forces here. They are vertical, just like this. We need to write it in terms of this. But look where the angle is. According to where the angle is, if you complete this triangle like this, you're going to have 90 degrees. So according to this 30 degrees, this is the adjacent, because you want to calculate this side. So this is your adjacent. Remember from your mathematics, guys, that's where you have angle and 90, that's adjacent, and this is opposite. We are not talking about this. We want to calculate this. We need where there is adjacent. So whatever that is adjacent, guys, from our soccer tower there, it's what? It's cos. So which means this part here, which is the adjacent part, which is the R that we are talking about here, is going to be F cos 30 degrees, like this. F cos 30. Remember, guys, from your cos that cos 30 is equal to adjacent, which is the one that you want to calculate. Let's just use r over the hypotenuse, which is f. So you just cross multiply. So r is equal to f cos what? F cos 30 degrees. But you must know that whenever you are given adjacent, you use cos. So r there is f cos 30. So we now have this part here with this force. It's f cos 30 degrees. Okay. So since we have the support r here, just like what we had on these supports, we know that we can take advantage of moments now, because if we take moments about L, we are going to formulate an equation there by taking moments about L. Okay, what am I trying to say? Okay, I want you to see something. We want to formulate an equation here by taking moments about L. All right, so taking moments about L. About L, which is, we have decided to say this is L and this is R. So we know that, guys, we shall have our same concept, moments from L, where we are going to have this R back, which is the anti-clockwise moment, which is the force times distance. So it's supposed to be R times the distance, which is 5. So this is what we're supposed to have. We're supposed to have R times the distance of 5 like this. All right. This is r times the distance of 5. But if you are to cross-check, this is the direction here. Let's cross-check this direction. Which direction are we using there? This is actually anti-clockwise. These ones, they are going this way. This 120 and this 200, they are going this way. They are going this way, which is clockwise direction. All right. But we do not know this distance here between x. So we are supposed to calculate the distance, because we are given this is x and this is x. So we can form an equation there, because we need to equate this. Okay, so let's start with this one. 120 times 1,2. So it's 120 times 1,2, force times distance. So we say these are the anti-clockwise moments. Sum of the anti-clockwise moments is equal to sum of the clockwise moments, something like that. Okay, so now we need to calculate the value of x. So where can we have the value of x, guys? Because we are supposed to multiply 200 times the distance here, but we do not know the distance because there is x. All right, this is what you're going to do. X indicates that these two are equal. This is x and this is also x, so these two are equal. So you're going to add 1,2. We're going to form an equation from our mathematical skills, guys. Let's form an equation. 1,2 plus this x here. If we add all these, we are going to obtain 5. That is the distance between here, which is 5. So we're going to obtain 5. So 1x is 2x, so 2x is equal to, we subtract this on the other side. That is gonna give us something like, let's just do this, is 5 minus, that's 5 minus 1,2. All right, which is something like 3,8. All right, then you divide by 2. So it's 3,8, you divide by 2, that's gonna give us 1,9. So you're going to obtain 1,9 meters. So it means x in this case is 1,9. This is also 1,9. But remember what we needed, guys. We're taking moments about L, and we said we've got 120 times 1,2 back to L. So you're supposed to take 200 back to L. So we have got 1,2 plus 1,9. That is our distance now. So 1,2 plus 1,9, which is going to give us 3,1. So that is what you're going to have in this case. So it's plus 200 times 3,1 like this. All right. So formulating the equation just like what we did on the previous part, we are going to end up with 120 by 200. So let's just see, guys, what we are going to have there. which is 120 by 1,2. That's 1,2 there. Plus you add the other part, which is 200 times 3,1, which is 764. That's 764 there. Alright, then divide by 5 by 5. Definitely our R is going to give us something like 152,8. So as we can see that this was in kilonewtons here. This was in kilonewtons here. So we shall have this in kilonewtons. But now we worked with this as our R here. Okay, so now this is our R in kilonewtons. So interesting part is that we can now take this R, which is 152,8, and equate to this R that we are given, because we said R is equal to F cos 30. So we now have the R that we wanted to calculate in terms of the actual force. So it means we are now going to say, since R is equal to F cos 30 degrees, so we are going to have F cos 30 degrees is equal to the answer that we obtained, 152,8 kilonewton, like that. So to find F, you simply divide by the cos 30. So F is equal to this answer that we had, divide by cos 30. So you divide your answer by cos 30 degrees. All right, we close this bracket, which is going to give us 176,438. Yeah, 176,438. 176,438 kilonewtons. So therefore, that is the F that we are given to calculate, which is the turning moment about that point that we are given. So as you can see, guys, this is how they can actually ask these typical questions. So what you need is to work alongside the questions that you are given, so that you can actually understand what's happening there. So that's what we had, guys, on this question. So like I said, we could have maybe worked with this direct, but you could just calculate your R as usual, as you know your R. Then you use that R, because you know that R is equal to F cos 30. You can formulate an equation from there. But these are direct moments. These are moments which they are just trying to twist in another way. They are just trying to twist these questions, but these are actually moments, as we know. So that's it, guys, from Mason African Motives, working on engineering science and 3 question papers and revisions. Till we meet again.